So, friends, I'm back. Please confirm your availability so that we can start the session. Uh,
Yes, sir.
yeah, thank you.
Well,
Thank you. Yeah, thank you. Yes. So far we have seen some aspects and terminologies related to the Databricks along with the Spark. And just now we have finished some of the scopes related to the ecosystem. Okay, all these kind of the conventions we have seen. Now, apart from these kind of things, I want to give you the essence of. Maybe by this time you would have realized that majority of the aspects are revolving around the Apache orientation. But what is the convention of the Databricks? Of course, already I have given some sort of the Databricks community edition support. Now, one more important aspect. So, just to have a look on this convention, like how the Databricks is giving the essence of the Spark. This is one thing, and especially we are talking about the Azure orientation, friends. As I said, whether that is AWS or GCP or Azure, there is no differentiation in terms of the programming or in terms of the job submissions and all. But only the thing is, which are all the offerings related to the Azure and how the Azure Databricks and as well as the Microsoft are performing the aspects related to the programmer. Now we'll spend some time to understand these particular points. And once this task is over, then we're free to study about the Spark design philosophy. Maybe in between, I will introduce you some sort of coding like RTD and all these kind of things. Now let us have a look on this. What exactly the Databricks kind of the convention and how it is allowing us to perform the activities. Friends, Spark, of course, which is basically again, if I am going back, so as to refer what exactly the Spark orientation is, just we can have a look on this convention. It is an open source, simple and easy to use in-memory processing engine, and which is providing the computing platform. Most importantly, Spark is the unified engine which supports SQL, streaming, ML, and graph processing. Okay, so basically, this Spark is one kind of the platform which is following the in-memory processing engine so as to avoid the disk-based kind of the access. And moreover, it is parallel and distributed aspects are observed in the implementation of the Spark. And in a single liner, if I want to explain or if I want to give the definition of the Spark, it is a unified engine which supports the SQL, streaming, ML, and graph processing. Okay. Now, along with the above mentioned things, if I am making use of the Databricks support, because the title of the course itself is a Databricks, so we are studying the appropriate Apache Spark in the context of the Databricks. So this thing we are clear, like which is the unified engine, okay, which provides some sort of SQL support of the machine learning, streaming. Okay, just to remember these points, friends, so that you can proudly say, suppose what exactly Spark and all. Now, if I'm running Spark on top of the Databricks, as said earlier, I can run Spark either on ARM or else the Mesos or else some standalone, whichever, or virtual machine or something like that. But if I happen to select this Databricks, like maybe that is the community edition or else the proprietary edition, whichever. Which are all the other conventions, which are all the other aspects I can avail. Before talking about these kind of the terminologies, friends, let me share once again that whatever the cluster we are running on top of that, just we are making use of that cluster again, which is giving some sort of the convention. where your cluster is providing the advantage of, okay, identification of all the other kind of the aspects. So here I'm having the cluster. Just if you are making use of the environment, this is the Databricks environment, where itself it is providing data science and engineering and machine learning especially. Machine learning basically provides, as I said, which is providing some algorithms and all those aspects. Whereas this data science and engineering provides you data pre-processing and all the encoding techniques, missing value impression, all those aspects. Okay, right. Now, after that, with the help of this Databricks edition, you can create the notebook, table creation, cluster, auto ML experiment. And we are using these two actually, notebook and as well as the cluster. Table creations are helpful whenever you want to populate some data. Like in SQL, how you create the table, all these kind of the things. But what we'll do is, guys, just we'll pick up the data from the external source and we are making use of the convention. Okay. If people are not talking, Elias, can you go on mute? Let me.
Okay, okay, sorry.
No problem. It's okay. Yeah. So if you are having doubt, then you can come. Okay. Right. So and then the other thing, guys, actually workspace actually. All the latest. I used to give trainings on other people like who are having the machine learning or data engineering kind of the certifications for the sake of mentoring and all. So this is all the appropriate information, okay, are already popped up, okay. So the recent things, and if I am selecting this thing, it is giving the prepared content. Just now we have created these kind of the content, and apart from that, I've created some other aspects. In a while, we are going to talk about these conventions also. Now, apart from these workspaces, we're having the recents, all the recent notebooks or whatever we have done. And most importantly, friends, your data. So this data, which is nothing but, suppose if I want to pick up the data from the external sources, if you observe, just this you consider the create table option, just there are certain menu items here, guys. Upload file, S3, Amazon S3, DBFS, okay, Databricks file system, and other data sources, maybe any other kind of the tools. Now, majority of the times we use these two actually, because as we are using the community edition, as we are not having any separate cluster for from Amazon or something. So upload file, DBFS. First, let me introduce this the DBFS. Okay, Databricks file system. Friends, here generally our files are available with the file store, and there are some tables. Just you can see all these kind of the conventions. Okay, so online retail data set. Okay, and all these kind of the conventions, sample spreadsheets, all these things. Okay. Now, periodically, I will be explaining all these kind of the things, how we are going to pick up the data, how to store the data. Now, if you consider the upload file, there are two options. Like in the first thing, I can able to select these kind of browsing option, and I can able to select the appropriate file. So by selecting this kind of the convention, only from the DBF, select DBFS path, whatever the path you want to maintain. So maybe I generally prefer storing of the files with respect to files store slash table slash maybe file one or something. Here you can save the data. Or else the best option is drop file upload or click to browse. So just this is opening our local file system, whatever the files I'm having. Just what you can do is just you can make use of the convention. So generally I placed our data. So Databricks, just you can use this day one and yeah, let us see, day two. So just I'm having the sample data, whatever friends, CSV or JSON or whichever. So just you can open that. See, just it is creating your sample.csv. Don't take anything. Just you can go back to DBFS and you go to the file store, click on the tables. Just you can see sample somewhere you can find out that particular sample. Yeah, this one sample.csv. So directly I can able to load the data and perform the activities. And my strong recommendation is, guys, suppose if you are saving the data, that data will be stored directly into the DBFS slash something. Whereas if you want to access the data, just to remember this particular path. Okay, so in all our community kind of the editions, this particular path is by default. Okay, just you are making use of that particular path, and I will be showing you how we are going to pick up that particular data so as to create the RDD. RDD can be created instantly, or else you can create that RDD from the external source also. Okay, so both the things we are going to talk, and I will be giving you like CSV, JSON, Parquet, all these kind of the conventions. And for ORC and all, we need to have Avro and all these things. We're having some external things, but we are rarely use those kind of the options as the source data. But otherwise, JSON, CSV, Parquet, these are all the basic conventions we generally use to process our data. Okay, this is one more option we need to explore. And then computing, this computing, friends, actually the load of the cluster and currently which job we are running, all these kind of the aspects. And here the tabs are there actually, all purpose and job compute. So maybe as we are using the computing community kind of the edition, we may not have the access to all those kind of the options. If you click on this cluster, already we have seen configuration and a notebook attached to this particular cluster, and which are all the libraries. There are no libraries. Event logs, which is definitely useful. If any problem is there for the cluster, or if any problem is there for a particular node, then the admin can generally jump into this particular event log. And Spark UI, which is a provision for configuration and all these settings. As our friend asked, can we do the manual configuration? Actually, some to maintain the persistence, so as to change the partitions. Yes, we can manually do some kind of the configuration from the program itself. Whatever the code we are using, from that particular code, we can manage the convention. Okay, see all these kind of the outputs and as well as the metrics. Okay, the file sizes and all the time-based requirement, all these things can be observed. Apps, other apps, okay, web terminal, and here we are unable to get these things. And generally, in the AWS or Cloudera, Heart and Works kind of the cluster, we are having the access of, okay, all these web terminal and as well as all the other kind of. For cluster UI, which is the master, I'll be introducing these terminologies, friends. Actually, driver, master, Spark session, Spark context, cluster manager, executor, jobs, stages, and as well as the tasks, and thereafter slots. All these terminologies before completion of the session, definitely I am going to introduce those kind of the conventions. So to notify you, just see the Databricks edition. Just the community edition itself, it is providing various aspects, friends. Whereas if I'm making use of the proprietary edition, definitely we are going to have much more functionalities. That is for sure. Now, just we have seen earlier aspects like how do we manage this Spark as a basic Spark session kind of thing, and as well as the Spark context. We know that Spark context is tightly coupled with the RDD orientation, whereas Spark session is something like which is most recently like 2.x and 3.x. Just we are having the Spark session, which is embedded Spark context, Hive context, and SQL context. Okay, that is the advantage. So before starting understanding of the RDD and all these things, let me clarify our Databricks support for the Spark orientation. One by one, we'll see, so that you can also have some sort of the understanding. Now, some of the terminologies we have seen here, friends. Databases and tables, administration controls, workspace or notebook, cluster we have seen, auto ML flow we have seen, SQL aspects, and Delta Lake I will talk separately, friend, because the biggest success factor of the Databricks is the Delta Lake. Okay. Probably in a Monday session, definitely I'll introduce this Delta Lake and optimizer Spark. Now, optimizer Spark in the sense maybe that is the broadcast variable or else cache or some sort of the UDFs. And some other thing is there, friends, actually hash map join. Okay, these kind of the conventions are very much helpful. Through programming, you can manage the configurations and all these kind of the performance. So simple. Databricks is a platform which provides these clusters, workspace or notebook or administrative consoles, databases or tables or SQL analytics to the programmer. However, the developer having the flexibility of Apache Spark API, maybe he can use either RDD API in the low level or else maybe he can make use of the high level API such as the data frame. Okay. So that means along with the Spark, just will be having this additional infrastructure provided by the database. Okay, so we cannot separate these two. To run the Spark, we should have the support of the database, maybe in terms of the cluster, maybe in terms of the notebooks, or in terms of the data, whichever frames. Okay, we cannot see separately Spark and of the database. And we may ask this question: if I am using the AWS or Cloudera Manager, do I need to use the database? No, you need not, because Databricks is one environment or one placeholder or one platform where you can venture your coding and all these kind of the functionalities. But whereas if Indium provides us some sort of AWS or Cloudera, Hortonworks or GCP or Azure, then we can directly make use. And even Databricks Community Edition we are using, maybe we are going to get the Databricks proprietary edition also, which is having full-fledged optimizations and data lake, all these kind of the conventions. And one simple difference between community and proprietary is community. Suppose if I am running the complex application, it takes more time, guys, because only one cluster we are having with two cores with 15.2 GB data, like that, 2 GB allocation. But whereas in real cluster, we may be having some terabytes of the data, so that you need not wait that much time to submit and execute the appropriate job. Okay, so now coming to the other thing, I'll try to give you the what is the support of the Azure. Okay, maybe we have started somewhere like Spark, and we are happy to see the support of the Databricks. So, like Spark, which is basically unified engine. On top of this particular Spark, I'm having some cluster support, notebook support, and Spark UI. Okay, as of now, just we are familiar with these things. Now, if I am adding Azure also to my toolkit. So, however, I'm having the Spark Unified Engine. Along with that, I am having the support of the Databricks. If I am naming that thing as Azure Databricks, okay. So now, what would be the other functionalities? Because always people say that Spark versus Databricks, Spark versus Azure. Okay, now there is a clarity. Spark only comes with unified engine has to perform the ML based aspects, analytical kind of things. And one more thing is streaming, all these aspects. Whereas your Databricks provides some additional tools so as to implement the programming model. Like, with the programming model of the Databricks, one can achieve the notebooks. Through that notebook, we can feed the commands or whatever the code we are having, and we can make use of the assignment of the clusters and all the other conventions. Sorry. And now, if I'm taking the Azure platform, uh, this is again providing the additional services, friends, because Microsoft is famous for the Power BI kind of thing. That means you can easily integrate your Spark with Power BI. which is nothing but a visualization tool, some sort of the messaging services, data services, unified Azure portal, and unified billing. Because there is a billing like per user per month. Okay, like that we're having billing, and based on your workload and based on your whatever the functionality you are using, accordingly Azure is billing us. And not only Azure, AWS or GCP also. Azure Active Directory, Azure DevOps, ADF, Azure Data Factory. Okay, these kind of the conventions are really empowering our learning. And of course, Azure is having its own ML stack actually. So more or less, guys, this particular Azure, what it is giving is whatever the Microsoft products we are having. So we are going to integrate those particular products along with our Spark. So because by default, Spark is providing some sort of the RDD and data frames kind of the APIs, and you can easily integrate these APIs with all the mentioned toolkit, maybe Power BI, sometimes Tableau, okay, Azure Data Factory, data services, okay, whichever the means. So we need not worry about do I need to learn Spark and do I need to learn Spark for Databricks? Do I need to learn Spark for Azure? Nothing like that. And moreover, even the concept of the machine learning, pipelining, data engineering aspects, all these things dependent on the RDD and data frames. Once you are familiar with the RDD API, data frame API, and Spark SQL, you can run your you can implement or you can develop your applications in any zoner frames without any problem. So that's what I'm saying. So just you prepare whatever the topics I am teaching in the session without any ignorance, and then just I will be giving some sort of the task to you with some examples and all. Okay, so just to try to solve those kind of the examples, and my strong recommendation is architecture wise you should be very strong, friends, because if you are not able to understand the architecture, so it is very, if you are familiar with the RDD or data frame, somewhere you feel the disconnect actually. Because once you are happy with the understanding of the architecture, definitely your programmatical skills will map with respect to the architecture, so that without any problem, you can make use of the convention and you can have a look on that how do I implement these kind of the aspects in a specific or in a generic way. So just to try to understand these kind of the aspects in a more attentive way. Okay, and now the most awaited aspect, which is definitely the architectural aspects, and I thought of starting with the Spark design philosophy. Rather, in the next session, definitely I'll start that philosophy, because that philosophy is having four different aspects like extensibility, modularity, and as well as the appropriate transformations like RDDs and all these kind of the things, ease of use, okay, where, with the help of these kind of thing, and speed, of course, obviously. So these four things are having some sort of the understandings and applications related to RDD and all. Okay, now a simple thing I want to give you, like just I want to place some kind of the third party project friends here, where you can feel the observation of how you can see the projects related aspects. Okay, before jumping into the architecture, so just I am warming up you. What is the capacity of our Spark? Okay, just various packages, infrastructure projects. Okay, these many kind of things, and how Spark is really booming up and doing the things with other companies. Friends, you can easily see that. Meso still in under force, but majority of times we'll use the ARN kind of thing. Zeppelin is another tool, is excellent. Like that IBM Spectrum, okay, ML Flow, Delta Lake. However, we are going to talk about that. And applications of the Spark, using Spark, Apache Mahout actually, friends, now the scikit-learn is really doing well compared with Mahout. It's a library actually. Apache Mahout is a library which provides some sort of machine learning kind of the applications or all these kind of the things with respect to the MapReduce implementation. And have a look on these kind of NLP. Excellent aspect because see two important aspects. Maybe 90% of the people are data engineers or data scientists. Believe me, friends, though the path is very tough in terms of NLP and deep learning, maybe the persons who want to settle down fast and who want to have some kind of sound career path, believe me, guys, with NLP and deep learning, such as CNN and RNN kind of things, we are going to have excellent future. I mean, though machine learning, data science, and data engineering, out of 190 percentage of the job requirements are like that, and people are also available. Though out of 100, only 10 jobs are there, but only one or two members are there for this NLP and deep learning. So just I'll float once this thing is completed. Definitely, I'll float that NLP and deep learning aspects also because as a data scientist or data engineer, we should know about the downstream technologies also, friends. Okay, so definitely I'll keep on posting about these kind of the NLP and deep learning kind of aspects. So definitely, based on your manager recommendation, please do attend those things also. And performance and debugging kind of aspects. I just to try to explore more things, friends, because ultimately any programming language or any tool, we need to expect some sort of the performance aspects. And additional language, okay, Julia or all these kind of the conventions. And one more thing, these GitHub already I have shared with you. Just if you are referencing. Uh, okay, no problem, Sanjay. Okay, take care. So just to have a look on this GitHub and all, right? Okay. So this is what the strength of Spark, friends. And see, Spark is a version as all any other subject. How, but one understanding of this thing is in the Spark we can take the beach view, like in Surathkal, how we are taking the beach view in Pondicherry, how we'll take the beach view in front of the universities. So like that, as a learner, we are having the flexibility of making use of that convention. Okay, so let us try to preview those kind of conventions. So this is how you achieve the convention of Spark orientation. Now let me introduce you what exactly the Spark architecture in a simplest way. Okay, so generally, friends, I pick up these particular data from the either Apache or Databricks because so many other blocks are there, and maybe they are easy or something. But the proprietary language or the proprietary kind of thing, the authenticated, because in terms of the certification, in terms of the implementation, definitely we need to verify those kind of the conventions only. Okay. Now have a look on this diagram, guys. So just think through. First, let us see each and every term. Then we'll discuss what is the architectural aspect. Okay. So the very first thing is the driver program. In Java or in any other programming language, driver means main function. And your Spark context is the entry point. Okay. Now the third thing is cluster manager, which is responsible for resource allocation. Okay. Now this worker node, friends, where your job is going to run, job running machine, and we are having the executor. Friends, here executor provide the slots. These slots are for tasks to run the tasks and all. Now, if you observe this diagram at the outset, okay, don't go beyond friends. Just be with me, okay? Because this is the basis for our Spark architecture, and I try to inject as simple as possible. Uh, at the outline of this particular diagram, you can see that there is a direct communication between Spark context and as well as the cluster manager, and Spark context as well as the executor. Have a look on it. Your first thing is communication between Spark context and cluster manager. Your second and third paths are showing that Spark context is having the direct communication with the executors and all these kind of the tasks. Okay, I mean tasks directly rather than executor. Now, within the executor, again, worker node, I'm having the executor with task support. Okay, those particular tasks are something like where actually, friends, is a slot. Slot is a space to execute the program, or slot is a place to execute the corresponding task. So, if the executor is free, that can be named as a slot. If the executor is something, hope you got the point. Executor, if it is not running the task, it is a slot. Free slot, I can say. Free slot. Whereas if executor is running some tasks, okay, executor is running, okay, then it becomes the task. So obviously, our Spark context requires the slots, not the tasks. Because Spark context, let me give you this. Spark context initially interact with the cluster manager. Cluster manager is responsible, okay, to manage the resources and to assign the resources and to teach the executors um, along related to the job running. So the cluster manager is having the idea about how many executors are there and how many slots are there, how many tasks are currently running, the entire aspect. Because he's a manager, no? Manager should know everything. Like cluster manager also having the convention on it. But the most important point is cluster manager is not going to involve once the resources are allocated to the Spark context. A little bit tricky, friends. Here, cluster manager initially lies in between Spark context and executors. Once that cluster manager is okay with allocation of the task to the Spark context, it only gets the updates, friends. It is not going to involve anymore. From now onwards, this executor and Spark context are having the direct communication. That means Spark context can place the job requirement to the executor. The executor is assigning the appropriate requirement to the slots. Now task is going to run. Once it is direct update, so get plenty of the questions in the certification also, friends, because this understanding of the Spark architecture is understanding of the terminology, because driver program is something like main, and maybe sometimes you may have that Spark context or Spark session. Don't worry about that. If it is Spark session, then you need to understand that it is having Spark context support, Hive context support, SQL context support. No need to worry. If it is Spark context, perfect. We are using the RDD orientation, and of course, either the Spark context or Spark session, they are the entry points. They are the entry points. Of course, they are the Spark context or Spark session are directly connected with the cluster manager. Once the cluster manager do a go ahead to the Spark context, now Spark context is not going to disturb the cluster manager. Because once the project has been allocated to us, you need not go back and verify with the manager, because there our team members would be there, some seniors are there, and module manager would be there. Okay, automatically we are going to interact with our nearby managers. So here also the executor and all these kind of things directly go back and update the context.
Sir, sorry to Interrupt, but your
Yeah.
voice is breaking.
Wait, just 1 minute, 1 minute. Let me connect one more device. It is it goes now, so it is. Sorry, guys, and please do inform if any such glitch is there. Just let me. Extremely sorry, guys. Yeah. Can you confirm now it is okay or
Yeah, it
still?
is fine now.
Yes, sir, it's fine now.
Fine now. Okay. Thank you. Thank you, guys. Yeah. I thought of putting these things only, but suddenly that air I thought of maybe. Okay. Right. Uh, yeah. So up to this, any doubts, friends? Maybe between Spark context, cluster manager, executors, all the cache I will come back. Intentionally I kept aside because now I don't want to get that particular caching mechanism because that caching is something. See, maybe I can put this way. Can you give the distinction between RAM, cache, hard disk or disk? Can someone maybe in the chat window or somewhere? Whereas if I'm having the active set of the program, okay, I'm running some sort of the program where your RAM is the main memory actually. Suppose whichever the aspects, whichever the conventions I'm using, all the frequently used conventions, okay, all already used data because there are certain footprints and I can make use of this footprint so as to access the data and I can say cache is the fastest when compared with the RAM. Okay, it is fastest. Uh, and suppose if frequently asked data or frequently already used data is not there, then the current program should contact the RAM. Then only it is going to pick up the data. So similarly here, friends, if you talk about the caching mechanism of the task running, suppose assume that one task is running and already the task has accessed some variable B. Assume that. So in that particular case, friends, obviously your B variable is available. Again, if the task want to get that B variable, it need not go to the RAM directly from the cache. It is going to perform the aspects. And one more important thing is already I have been keep on saying that RDD memory orientation and it is working with the partitions and I can maintain this RDD persist in the memory or I can cache the RDD in the memory. I'll come up with some case study friends because uh, understanding of the persistent at cache is not on the fly actually. Because in your program, if you manage any of the RDD as cache or persist, then there are certain benefits to us. Okay, those particular benefits are we need to study elaborately. So at this moment, what you can do is what you can understand is assume that here I am running multiple machines so as to perform some kind of the job. And all these particular machines are having some sort of the main memory. Okay, so because this is the in-memory computing now, I'm having the main memory. Um, what I want to do here is just I'm making use of some sort of the RDD, whereas RDD1 and with respect to this RDD1, there are certain other functionalities, RDD2, RDD3, RDD4, assume that. Now observe here guys, once this RDD1 is done, it is moving to the RDD2. Maybe suppose RDD1 has given the result forwarded to the RDD2. Then this RDD1 is no more available in the main memory because if it is keeping all the RDDs, there is no space for the new application. Because as we are always talking about the parallelism and distribution, the one of the important aspect all the Java programmers may be knowing garbage collection. Okay, periodically this particular procedure will be running and this particular procedure what it does is just it is keeping track of compaction you might be knowing keeping track of all unused objects least frequently used in that manner. So just they are collected by this garbage collection methodology and they will be removed from the memory. That we know in Java and all programming languages. Here also guys, in Spark, as this is heavily dependent on the in-memory computing, friends. So if you are making use of the RDD orientation while performing the current RDD, there is no previous RDD because this result has been forwarded to the current RDD. So your previous RDD won't be available. Now there is a problem. Suppose if any problem is there for RDD2, if RDD2 machine got failed, then what should we do? From the beginning, we need to start the task again because the result is not the whatever the result we got from this RDD1, that is not available in the memory. And our RDD2 is the current thing. It is also not available. So we don't have any clue. We are left with only the option to start the activity once again. To avoid this particular convention, what I can do is let me take one more thing. So RDD1, RDD2, 3 and 4. Now if I am making use of this RDD2 as persist, friends, persist. So assume that RDD1 completed and it forwarded the information to RDD2. RDD1 is no more in the memory, free. And RDD3, assume that RDD3 got failed. Don't worry, you need not start your activity from the beginning because your RDD2 got persisted. So RDD1 result is available. RDD2 result is also available. That is the advantage, friends. You may ask this question. Suppose RDD2 got failed. Again, you have to start the thing. At least, you know, if I am persisting something, I can able to perform the activity of this RDD2. From that, I can build up RDD3 rather than going back and verify. So this is what you call cache or persist kind of thing. And of course, I'm having a complete narration of 20 to 25 minutes, guys, because we need to have that complete understanding of the RDD persistent cache. Otherwise, you know, only 2 lines of the code for that, but the logic or analogy behind that we should understand. So based on that particular analogy only, we need to perform the activity. So now if you see these kind of the convention, now what I'm explaining here is guys, task is the lowest granular of the job. So job will be converted into the stage. That stage is converted into the task. Okay, so now task is the lower part. Okay, job is the highest entry. Job will be split into the stages. The stage again split into the task. Now this executor is providing some kind of the slots so as to execute the appropriate functionality, and slots are simply mapped with the corresponding task. Slot under running is a task, friends. If that executor is free, then you can see the slots. Now, if you observe, we are having two executors with no slots. That means all these executors are filled up with the corresponding tasks. And once the task is completed, the appropriate result is directly communicated with the Spark context. Okay, this is what how you can refer the convention of the Spark architecture. Okay, now let me give you the notion of okay, what exactly the functionality and how we are going to activate these kind of the things, because in the diagrammatical representation you can easily observe that how I am performing the activity and how I am in a high level view. But there are certain points we need to observe in the elaborated way. So I strongly insist you guys, these points you have to make a note, and some other points also I am pulling. So just these, if you observe these kind of the points, definitely you don't have any confusion while running the jobs and while answering the questions into the certificate exam. Okay, now let us start with one by one. Don't worry, maybe it is 10 lines or whatever. We'll try to simplify that. Spark applications runs as independent set of the process on a cluster coordinated by Spark context in your main program. That we pretty accepted because, you know, driver program and all these kind of the conventions, they are all related to the Spark application. Okay, we're having the Spark application. Before reaching to the application, definitely we should start the main, and within that main, we're having the Spark context. Okay, right? That's what we are reiterating. So Spark application run as independent set of the processes on a cluster. Okay, so process one, process two, process three, like that, coordinated by the Spark context. Friends, one thing, one Spark context is there because multiple main functions won't be there in the program. Na? Like that, one Spark context object is there in your main program. And Spark application run as independent set of the process in a cluster. Okay, the same thing called the driver program. And specifically to run on a cluster. Okay, friends, here however, we are running the cluster. We are running on top of the cluster. Actually, now if you see the Databricks Community Edition, we are running on top of the cluster. So in that particular case, Spark context can connect to several types of the cluster managers. As I said earlier, maybe that is the standalone cluster manager, Mesos, which is the default cluster for the Spark, or ARN, which is yet another resource negotiator, which is basically Hadoop ecosystem cluster management tool. So, but ARN is very successful cluster management tool. So the combination of the Spark and ARN is very good. Kubernetes, sometimes, the tailor-made kind of the clusters can be there, which allocate resources across applications. The main functionality of the cluster manager is to allocate the resources that already we have seen. Like initially, Spark context is going to initially establish a communication related to the cluster manager. The cluster manager responsibility is allocation of the resources, because directly Spark context is not going to touch base on the executors directly. Rather, what it does is just it is initially interact with the cluster manager, and from that cluster manager, it is a liaison. It is going to establish a kind of the two-way communication from executors and as well as the Spark context. Once connected, see, this point is most important. Spark acquires executors are nodes in the cluster, which are processes that run computations and store data for your application. Okay, these executors are nothing but the workhorses, actual running of the task. Okay, so once that particular task is executed, next it sends your application code defined by jar or Python files, pass it to the Spark context to the executors, because Spark context is having some kind of the coding, maybe in terms of RDD or data frame or whichever. So that particular code is hand over to the corresponding executors. Spark context send task to the executors to run. Now this Spark context is responsible to liaison between the cluster manager, to interact with the executors, to whatever the slots allocated by the executors, to those particular slots, the tasks should be supplied. So the Spark context is one of the important component, friends, no matter whether that is the Spark context or Spark session. Because generally, if I am making use of the Spark context, I am sticking to the Spark relevant aspects only. That means RDD indirectly. Whereas if I am making use of the Spark session, it should be understood that like this. Spark session is the combination of the Hive context, SQL context, Spark context. All the three things are inbuilt related to the Spark session, except that all the communication is same. Maybe Spark context or Spark session initially communicate with the cluster manager, and then it is communicate with the executors. And in the next step, Spark Spark context or Spark session are submitting the appropriate requirement of the jobs to the executors, and it assign the task to the slots of the executor. Okay. Now the next steps. However, once up to this, only job submission happened, guys. Okay, in the first portion, these particular steps, we explained what is the Spark application, what do you mean by the Spark context, how the cluster manager behaves, what exactly the executor does, what do you mean by a slot, how a task is assigned to the executors, all these things you can observe here. Only what we have done is whatever the diagram we have seen here, as it is, we are converting those diagrams into the textual fashion. That's all. Okay, because maybe by seeing that particular diagram, you may be not in a position to elaborate those things. That's what I thought of Don't miss out the functionality of the Spark architecture, because this is the basis thing. Suddenly, if I am asking you what is a slot, you should say that free locations or free resources available in the executor. What do you mean by task? Task means the appropriate Spark context occupy the slots so as to run the application. That is a task orientation. Like that, you need to observe. Now, if I'm asking you like a question, uh, Spark context individually is having access with the executor, or it should access through cluster manager? Your answer is no. Spark context need not depend on the cluster manager, because already cluster manager approves the request of the Spark context or Spark session. From now onwards, your Spark context or Spark session is having the communication with the executors. So executors reply back to the Spark context with the results. Okay. So like that, you need to observe. No problem, friends. First time, if you are feeling any difficulty, because as I'm regularly working with these kind of thing, I may be feeling that okay, some simple thing, but definitely for some of the members, it may be some kind of intrinsic. But don't worry, that is absolutely fine. It's okay. Only the thing is, you need to go back and just to go through this architecture and all these things. Because why I am insisting this part at the ending of the session is because this is the most required thing. I cannot say important thing. Required thing in the sense maybe in RTD, maybe in the data frame or optimizations or whichever in the certificate exam also. These particular points should be very clear. Okay, in the implementation perspective also. That's what I'm taking this much time so as to explain these points. Okay, I don't want to skip this important required aspect. Okay, and next thing is, guys, each application gets its own executor process which stay up for the duration of the whole application and run tasks in multiple threads. Your parallelism plays a vital role. Can someone give me the difference between? Let me give you the thing, friends, here. What is the difference between process and what is the difference between process and thread? Process versus thread. Okay, just think through, guys, because we are using that particular terminology. So I want to ask you this kind of thing because directly I'm using the term thread. Okay, please do give the reference so that other members also can get. Otherwise, I will clarify. No problem. Okay. This has the benefit of isolating applications. Okay, maybe if you are studying the databases, friends, if you studied the database, there is a concept called acid property, atomicity, consistency, isolation. Okay, individualizing the thing from each other. On both the scheduling side, each driver schedule its own task, and executor side. So tasks from different applications run in different JVMs, because as we are always striving for the parallelism, it is always important to isolate the things, because otherwise they overlap and they create some unnecessary results and okay, which fires back us. So that separation and isolation is important. However, it also means that data cannot be shared across different Spark applications without writing it to an external storage system, which is very, very important point, friends. Okay, so on the fly, definitely we are not able to perform the activities, friends, because temporary results are we cannot believe that temporary results. If you are having familiarity with your consistency and atomicity, temporary results are generated by the database or transaction, but we should not consider and we should not worry about the temporary results. The results once stored into the disk or a stable storage, then only we can able to consider. So here the point is obvious, guys, because the temporary results, whatever generated by the jobs, need not be reflected or considered by the other things. If at all you want to consider, again, the same convention. See, it also means that data cannot be shared across different Spark applications without writing it to an external storage system. And agnostic to underlying cluster manager, because it is not aware, because I cannot have any idea about God. That means the agnostic. No, I don't know, but I'm believing that due to some functionalities and due to some okay, all the observations, one can believe that, because Spark is also not having any idea. It is completely unaware of the cluster manager. It is simply okay. So only the Spark context or Spark session are aware of this cluster manager. But Spark feels that Spark itself is a cluster management tool, okay, which is having its own standalone kind of thing. So it is not worrying about the underlying kind of thing, because the Spark application or Spark context need to take care about the running of the jobs. That is how we need to see. And as long as it can acquire executor process and these communicate with each other, it is relatively easy to run it even on a cluster manager that also support other applications. Like, one of the important aspect is, guys, allocation of the resources. Okay, allocation of the resources. Now tell me this point. When we are going to get out of memory exception, friend, generally out of memory will get whenever there is no RAM availability, or else whenever there is no hard disk available. Okay, so while running the Spark application, until the appropriate resources are happy, we are not getting this out of memory. Your Spark is running process, no matter whether that is a Mesos or ARN or Kubernetes, whichever. Okay, so the way of running allocation of the task is absolutely similar in AWS, GCP, or your Azure. Similar to that, maybe you are using the community edition, maybe you are using your own virtual machine. In all these kind of the aspects also, you need not worry about the running of the task until if you are getting the out of memory, then only your Spark is understanding that, oh, this guy is running on this machine, because Spark never minds. Okay, if it is minding means, again we need to set up so many aspects. See how I am running in my virtual machine, how I am running in my AWS or Azure, or maybe in terms of cluster. Absolutely without any change, I can submit my job to any of the cluster across the globe, friends. There is no restriction. So for cluster, you need to configure this thing. For virtual machine, you need to configure. No such kind of the conventions. Okay, you can use your applications, or you can use your RDD or whichever without any hassle to any kind of the cluster. Okay, I don't want to overboard you guys. Just let me give you the key takeaways of the session, so that you can have a look on whatever we were discussing from morning onwards. So let me pull all these kind of the conventions. Okay. From tomorrow or day after tomorrow onwards, I'll ask somebody, okay, to elaborate on the key takeaways. The very first point is we start with Spark intro. Okay, where it has got started, and basically Scala and Mesos kind of thing. And then they came up with PySpark, and as well as ARN kind of the aspect. And then we started studying about the ecosystem, where basically we observed a solid cluster here. On top of that, we are having RDD. On top of that, we are having some data frame, like that streaming, other API kind of aspects. And this we have seen. And once that ecosystem is over, we have seen some Databricks community edition. How do I create the notebook? And to run this particular notebook, definitely we need to have the cluster. So just we need to create the cluster along with that. And in the Databricks community edition, we have seen that DBFS file system, where I can drop the file. So the default thing is DBFS, okay, colon, file store, colon, tables. Within this, we'll be having the file1.csv. So this is the path where we are going to pick up the data from the edition. And once that is over, we have seen the combination of the Spark, Databricks, and as well as the Azure. Okay, these three things and how these particular aspects are providing us some sort of the tools. Okay, now latest we have seen the Spark architecture. Friends, here Spark architecture gives us some terminologies we have seen, like Spark context, Spark driver, cluster manager, and then we are having executor. Within that executor, we are having slot or task, and the appropriate granular level jobs, stages, tasks. Okay, these kind of the terms we have seen. So in the next session, I'm introducing you the aspects of the RDD and how to create the RDD, some sort of the operations. Like, friends, there are two operations, transformations, and as well as actions. But these are all the operations. And then we'll see the most important aspect, friends, shuffle and partitions. Okay, tomorrow session definitely compared with this today's thing, it is very much easy for you guys. Easy in the sense only simple coding where you are equipped with all the RDD creations, usage of the actions and transformations, shuffle and partitions. In between some architectural aspects also I'll be touch basing, because if I'm not embedding the architectural aspects, you may not connect the dots, guys. Okay, that is my worry. And definitely I'll promise you guys at the end of the course, definitely we'll be having some confidence along with the level of the project implementation. Okay, so that is what from my side. So thank you for your cooperation and nice patience. And I need more replications from you guys. Please participate in. And in the today's session, no, Ravi has not given anything. Akshay, very good. Surendra has given the answers. Vedant, very good. Elias and Surendra again. Okay, Akhil, I know. And Vedant also. Sahu again. Shahrukh, and then Shanmuga, again Sahu. Okay, so these members given their I mean answers to the corresponding questions. That is very good. And of course, my your success, my success, friends. So definitely, if you are more involving and if you are more attentive, then definitely I can bring you some value added. Okay, it doesn't mean that the listeners are not doing anything, not absolutely that thing, friend. But I am requiring your response also so that I can see I'm happy. That's all. I'm happy to listen from you and I am happy to get some messages from you. Nothing else, guys. Okay, it's not a kind of restriction. Only the thing is if you are participating in the discussion, I'll be more happy. Okay, right. That's it. So thank you, Shanmuga. Here process, program under execution. Thread is nothing but path of the process or path of the program. Like I can give a best example. MS Word, if you are taking spell check, grammar check, and one member is editing, one member is taking printout. These are all the threads actually in the main application. Uh, okay, so Surya says no free slots. Okay. That means task means no free slots. Obviously, the task has been assigned to that particular slot. And Elias says process the execution of a program. Thread, of course, of course. Yeah, Ceci, definitely I will share that. Yeah, finally, what you will be getting is a class shell. I will be sharing with you. Class shell plus presentation plus notebook and any other tasks. Okay, like that, whatever the tasks we are having, definitely I'll be sharing with you guys. No problem. Okay. Hmm. Any other requirements, please update me, or else you can contact me also, friends. No problem. So if any doubts are there, and soon I'll be creating Slack so that you can post the doubts or all whatever the things we are having. Okay. Thank you guys. Nice. Always will get nice people. So just to prepare well and come back with your questions. We'll go slowly, no problem. Don't worry. And I'll be posting the tasks of the day also. Actually, I asked you one more time. Let me pick up that particular task. What is the task I pasted here is tungsten and as well as the um, catalyst analyzer optimizer, sorry, catalyst optimizer. Because those two aspects are very important, friends. Those two things are nothing but spark optimizations. Okay, so catalyst optimizer and tungsten. Okay, tungsten. This is the task one, friends. And I don't want to give more tasks today because just we have started now. And coming to the task two, what you need to do is just you study about uh, RDD because that we are going to RDD usage just to study. And task three, most important, the Spark components in the architecture. Okay, so just to see the architecture once more, just will be talking about the architecture. Just I'll be introducing some more aspects so that you can have a look on that. Okay, thank you all guys. So see you back. Just we are having some sort of the conventions. Hi Krishna, how are you, man? So happy to have you, my dear friend. So just
Yeah, Poonam.
how are you? Yeah, nice, nice. Okay, so very good. Out of your busy schedule, yeah, we are having you very fortunate, right? Okay. So thank you, Krishna. How is the session? Hope you enjoyed. So definitely,
It was
if
good.
any, yeah. Okay. So if any additional tasks or additional requirement is there, just you let me know, Krishna. So I need your, I mean, whatever the additional aspects I need to cover so that we are having that ideology and all. Na? So we are having some 3 to 4 months travel in the machine learning or data science path. Okay. So that's thank you, Jatin. Yeah. Very good. Okay. So thank you guys. And tomorrow onwards, the road is very simple because I thought of this thing, how I need to inject to you because Spark architecture, this ecosystem, all these things slowly, gradually, I could able to do that with your all your support. Okay. Thank you. And I'm so happy with suppose if you are giving me the answers in the chat window or if you are unmuting so that we can